Hi physics class. Today I'm just going to quickly do number 1 on the momentum review. We have a test coming up. Okay, so we got a ball traveling this speed, this direction. First I want to find the horizontal and vertical momentum. Draw this vector north of west. Remember, that's always opposite of adjacent. So west is our reference and we're north of that. So it's going to look like this. Okay, and I'll break that up into x and y. This is my 20 degrees here. Okay, so this momentum vector would be just the mass times the speed. Mass is 1. So our momentum is 1.5 kilogram meters per second. And we have x and y. Okay, x is going to be 1.5 cosine 20. All right, let me do that. Okay, I get 1.41. And that's going to be, I just realized, guys, I drew mine going east. It should be west. It won't change my calculations, and I don't want to make a new video, so it should be like this. Okay, x, y, 20 degrees. Ooh, maybe I could have mirrored this video. Whatever. Okay, so the answer is west, not east. Okay, and then y is going to be 1.5 sine 20. Okay, it's 0.51. And that's going to be north. Okay, moving on. After the collision, one ball's traveling 0.8 meters per second west. Okay, so we have to determine the final velocity of the other ball. I like that the mass is 1 kilogram here. So whatever the speed is, that's also the momentum. Alright, so here's what I like to do. I like to do total x equals x1 plus x2. And these are momentums. The total x is what we got here. Alright, so 1.41 west is going to equal 0.8 west plus x2. Alright, so x2 we just need to subtract. I'm going to get 0.61 kilogram meters per second west. And then total y is going to equal y1 plus y2, and I'll just do this quickly. Okay. So I've got my x and y momentum of the second ball after the collision, so I just need to draw this vector. Okay. I'll call it P2. Okay, and it's just going to be Pythagoras. Okay, I get 0.80. Alright, I'll work in this angle as well. This is the momentum, so I'll call it kilogram meters per second. I'll do the calculation, but I think you know it's pretty trivial here. The speed is going to be momentum divided by mass, which is 1, so this is also the speed, meters per second. This angle I'll get quickly. Okay, I get 39.9. I'm just going to call that 40 degrees. And the way I've drawn it is north of west. Okay, you could have got 50 degrees west of north, and that would be just as correct. Alright, now let's find out if this thing's elastic. EKI. Initially, there's only one ball traveling. Okay, so I'll still write it. I'll say it's, EK1 plus EK2 initially, but this one's 0, so The mass was 1 and the speed was 1.5. Okay, let me do that quick. Yeah, 1.125 joules. Okay, so that's before the collision. We'll do the same thing for after. This time they're both moving, so I'll have a bit more of a calculation to do. Okay, so the first ball is going 0.8. The second ball is also going 0.8. That's interesting. I just noticed that. Okay, I think what we're going to get here is 0.64 joules. So we have a loss in kinetic energy. This collision is not elastic. Alright, I hope this video helps. There it is in all its glory. Good luck on the test.